请 Sasaki 先生上台发言。
Well, I have to say it's very difficult to always follow really cool graphics in video games, but I'll do my best. I have to say that this morning we saw a lot of great news about Tizen. I'm very excited to be here in Shenzhen to talk about the Internet of Things and what it will mean for developers like you in the audience. I've been working in high tech for over 30 years. In fact, I was at Apple during the first early days of personal computing. And I worked with developers on the first phones with screens that had applications even before the iPhone came out. I was even part of one of the first demonstrations of a smart home with connected microwave oven, home automation features, and more at CES in the year 2000. So I can tell you from experience that the vision of IoT has been around for a long time, but not all of the technologies have been in place until recently to really kickstart this industry. So you might ask, why now? The answer is that we are finally experiencing a convergence of technology enablers which have lined up to move the Internet of Things from vision to reality. The first is semiconductors, where the performance, integration, and power efficiency have spurred the high growth in mobile devices. But with new packaging technologies like EPOP, they can combine to dramatically reduce the size of semiconductors and enables the creation of modules that's ideal for IoT. Second, a wide range of sensors can measure everything from acceleration to sound and light. And you see it today, they're widely used. A typical mobile phone has 9 sensors. But on a typical car, there's over 500 sensors. These sensors span not only consumer, but also industrial. You have sensors that can detect gas. Back in 2000, when we built our very first CES smart home, Wi-Fi wasn't even available. And mobile data was limited to a very unreliable analog cellular network. So the third key area is networking. Today there are many choices. Long-range 3G and 4G, short-range Wi-Fi, Bluetooth Low Energy, Zigbee, Cat 0 which is coming, and low-energy wideband options like Sigfox, LoRa, and on-ramp. Together, they create a wireless mesh of connectivity, but individually they're ideally suited for the devices they support. Because a cell phone has very different requirements than an agricultural sensor in a farm. And then there is the cloud infrastructure and the internet. With massive amounts of data, we can now develop new algorithms to do anomaly detection and pattern recognition. And for the first time, we have the data and capability to widely enable true machine learning. Put them together and you have the ideal platform for IoT. If you look at the market opportunities for IoT, you see major growth areas in smart buildings, health, and in transportation usage. All this combines to grow to a $1 trillion opportunity by the year 2020. All of these technologies will have a big impact on our personal and work lives, improving the safety and quality of life at home. We have solutions that will monitor our health in real time, will reduce our overall energy consumption, and provide safer solutions, such as even monitoring how water is used on farms. That's very important in California with our drought. IoT will also change how companies create value, and compete in the future. We are already seeing products in the market today. SAIC previewed the MG IGS smart car at the Shanghai Auto Show. And startups like EHAG and DJI are making drones. BodyCap even has an ingestible pill that can measure and transmit the body's core temperature in real time. And I'll show you what it looks like. So this is a pill. It's an IoT device that you actually swallow, and it tracks your body temperature in real time. It's pretty impressive. Look at the size. IoT has also made its way into tennis, basketball, and golf, where sensors and apps help improve performance for weekend athletes like myself. I recently got a birthday present. It's called the Zep Golf 3D Swing Analyzer. It can track the club speed, swing plane, tempo, hip rotation, and more. And what's even more fun is you can compare yourself to pros. IoT has made amazing progress, but there are still technical challenges ahead. When it comes to IoT, one size does not fit all. We need to balance size and performance for the range of devices. Some that are very tiny, some that will be smart lighting fixtures, there'll be drones, even home automation hubs. Many devices must operate on batteries in an always-on mode, which requires very efficient use of power. And of course, how do you manage interoperability and compatibility for billions of devices on shared networks as standards are still being defined and emerging? As we bring more connected devices into our homes, privacy becomes an even bigger concern. I'm sure many of you might have read about baby monitors being hacked. Security is critical for municipalities as they deploy and manage smart city infrastructure. Having a strong end-to-end architecture is required. Development must also be made easier. We've seen hardware design get more interesting with dev kits like Arduino and Raspberry Pi. We also have seen cloud-based programming environments that make it much easier for both novice as well as professional developers. At Samsung, we are committed to work on these technical challenges. As a global leader in semiconductors and connected consumer electronics, we have made a history of innovative products from semiconductors to consumer to industrial products. We are investing in developers, open ecosystems, and we have announced plans to connect all of our digital appliances by 2020 or earlier. And now, I'd like to tell you about our newest innovation, the Arctic platform. The Samsung Arctic platform is made of highly integrated hardware and software modules, which make deployment much easier and faster. Helps you build IoT products. The Arctic platform consists of a range of modules for different market needs. It includes a comprehensive software development platform, wireless connectivity supporting a range of standards, advanced security, local storage and processing power so that devices connect independently and intelligently, and cloud solutions. But most importantly, it's an open platform, so you as a developer can tailor it to your own needs. We start with 3 different hardware modules. The first, the tiny Arctic One. Let me show it to you. This is the Arctic One development board. So as a developer, you start by programming with the board. You plug in the display, USB, download code. Once you're done and ready to go to deployment, this is the actual module you would use in your end product. It's very tiny. It's 12 millimeters by 12 millimeters. The Arctic One has a dual-core processor, 9-axis accelerometer, 1 meg of RAM, 4 megs of flash memory, and Bluetooth low energy, all integrated into this very tiny form factor. It's also extremely power efficient. The Arctic 10 has an 8-core processor. It has 2 gigabytes of RAM, 16 gigabytes of flash, plus full 1080p video encoding and video decoding. It also has 5.1 audio support, plus Wi-Fi, Bluetooth, and Zigbee that's integrated. The Arctic modules are designed to balance performance, low energy use, and all in a very compact size. They can power anything from beacons, door locks, home gateways, smartphones, and wearables. But that's just part of the story. As you can see, our security experts have really thought through the challenges of always connected products from both the technical and user perspective. We start with an embedded secure element that encrypts a unique key at the production line, and we provide an end-to-end software solution. The software supports secure boot, trust zones. These provide firewalls. We also support features like on-device anomaly detection to further enable unique security solutions. We believe security is a key requirement that can help consumers feel more comfortable when using more and more IoT devices and services. The Arctic platform puts power in the hands of developers, so you can get up and running very quickly. It uses familiar open source software, like Tizen, developer kits, has open APIs, and support for standards like OpenHAB, IoTivity, and Thread. The Arctic boards will also soon support Arduino hardware and tools so developers can leverage the many sensor boards and the familiar IDE. We've also worked with Tembu, a very innovative startup company that makes developing for IoT incredibly easy. In fact, if you see some of the demos, you can create an application without writing a single line of code. Together, Tizen for IoT and Arctic are expanding options for developers. We're deploying these technologies inside Samsung, but believe the future of IoT depends on a growing ecosystem of products, developers, and partners. And we're making all these innovations available to you. The new Tizen IoT profile will make it easier to support efficient IoT products, while the Arctic modules will shorten development time for hardware and also cloud integration. Tizen 3.0 has already been ported to Arctic 5 and Arctic 10, so that you'll be able to have a complete platform for IoT development. And we're currently developing Tizen real-time for Arctic 1. But with billions of connected devices and sensors collecting all this information, we must not lose sight of what the Internet of Things is really about. It's all about the data. How do you collect and share information from so many different devices? We've thought about that too. With SAMI, Samsung has created an open, cloud-based data exchange platform, which can greatly ease the difficulty of accessing and using information from devices. How do we do this? By avoiding the complications of working locally and sending all of the data to the internet. where Sammy can easily ingest, disparate data from multiple platforms and manufacturers and make it instantly available for use. The cloud already integrates many third-party devices and other clouds, including SmartThings, which is a home automation product, and also with Samsung appliances. New kinds of analytics and machine learning services and applications are where we see the real value of IoT, and where developers will be able to build transformative new business models. But that's not all. Sammy solves the problem of device interoperability. Anyone who has tried to connect and control devices at home from hundreds of manufacturers currently available knows it's very difficult and sometimes impossible. Sammy provides a rules engine that allows this to be done easily and quickly over the net. Together, or individually, Tizen, Arctic, and Sammy provide an open solution for the Internet of Things. You can learn more about Arctic and Sammy later today in the technical sessions. To close, I'd like to talk a little about what we see happening here in China. The Internet of Things will touch people in many different ways. And in the early stages, there will be pockets of innovation where leaders have stepped up to solve more immediate challenges and identify local opportunities. We've heard that projects are already underway in approximately 300 cities. They include smart traffic and parking systems, smart utilities, grid technology, air quality monitors, and public safety. Oshi was an early adopter where they created an IoT demonstration zone, and now they've built an entire sensor network. Shenzhen's own China Information Technology has launched a production line monitoring app that integrates RFID, sensors, video, and other data to improve quality and efficiency. One of the winners of China Unicom's IoT Accelerator Technology Challenge, Vivo, is developing a supply chain management application that optimizes route management, monitors driver work hours and fatigue, and manages package delivery. Other major projects are in development, from self-driving smart cars to healthcare. It's an amazing opportunity, an amazing time to be in this space. Just as we saw the fast growth of mobile smartphones, we think IoT will grow even faster. I think the most incredible things are still ahead of us. Thank you, and we look forward to seeing all of your innovations.